Hello student, let us derive, today I am going to explain you how to derive the formula for the surface area of solid of revolution. So now just like in the case of volume of solids of revolution, if I take y is equal to g of x, that means f of x is a given function. And suppose the graph of this one is like this. Now we are to rotate, and suppose we are to rotate this curve about the x-axis in order to get the surface of that solid. By a surface of the solid, we mean that, for example, if you take this class, that means it will how to calculate the area of this lateral part. That means the lateral area of this class, for example, in this case. So now you see that if you rotate it about the x-axis, this is the y-axis, then in that case, the figure will be like this. See, this is from x is equal to a to this one, x is equal to b. So how to calculate the area of this one? So what you need to do is you cut this one. See, take this arc length from here, from the arc length from here to here, and then cut it in this way. And then you see that this will have some this arc length will have some the length of this one will be very small, but let us take it as dl. I cannot take it as dxy because it is not parallel to dl, or not parallel to the x-axis, because it is like this. And then if I take the radius of the middle portion of this, say, a band here, it as y, because it will be parallel to the y-axis. So let us take the radius of this portion here. And if you consider this class here, you can see that if I take cut this one class in the form of this band here, then you'll see that the radius of this band, which lies to the lower part of the class, is little bit smaller as compared to the radius of this band which lies at the upper part of the class. So that's why I neither take the radius of this lower part or the upper part. I'm taking the radius of the middle one. Then after that we can integrate it by taking, suppose this one is from x is equal to a to x is equal to b, so that we can calculate that one. Now you see that this is a band, and it is almost in the form of a circle. And what will be the if I take y to be the radius of that middle part, this one, y to be the radius of the middle part, then in this case you can see that if you open this band, then this band will look like this. Will look like this, where this is the middle part, and if the radius of that one is equal to y, then it will be twice by y, because it will give you the circumference of that band, which is in the form of a circle, by taking y to be the radius of the middle part, not the radius of this lower part which lies below this curve or above the or to the right side of the curve. So in this case it will be the surface area. But now since I have taken this one, you can see from this figure, since the length is like the length of this curve, so since there is some length to this curve, so I denote it by dl. Then in that case, if I take this one as dl, so what will be the area? The area of this band here will be equal to twice pi. That means if I take this as dl, the length of this arc from here to here or from here to here, the same thing only. So it will be twice pi y into dl. So this will be the area of this band only, that means this portion. But now since we are to calculate the surface area of this whole solid, the surface area of this whole solid after rotating it about x-axis, then in that case what will be the total area? The required surface area will be equal to integral, now from x is equal to a, because we have to cut this solid into the form of a band, into different not into different bands, but the band will be the figure of the band will be the same only, but the size of the band will be different. So into many bands you can cut this figure to get the area of that particular band. And after that you can integrate from x is equal to a to x is equal to b, which will give you the whole surface area of this solid here after revolving about the x-axis. So it will be twice pi y dl. But now see, the limit of integration is from x is equal to a to x is equal to b. But we have here not dx but dl. Now dl represents the arc length. That is the length of the plane curve. Okay, so the length of the plane curve. And in the last lecture, I've given you what is dl. The formula of dl, it is square root of 1 plus dy dx, the whole square dx, for the function y which has been expressed in terms of x. So you can replace this dl now by this formula. So finally, the surface area, I'll just write it as S. So the surface area is equal to integral x is equal to a to x is equal to b twice pi y into dl. dl is that one, the arc length or the length of the plane curve from x is equal to a to x is equal to b. So it will be 1 plus dy dx, the whole square dx. So now, whatever be the function of y in terms of x, you replace it here and then differentiate it and substitute in this formula. Then you'll be able to get the surface area of the solids of revolution. This is when y is expressed in terms of x, and then dl will be given by this one. However, if x is given in terms of y, that means if the axis of rotation is above about the y-axis, then in that case the formula will be similar to this one, but you replace y by x. So here you'll see that the formula for this case now, it will be the required surface area when the axis of rotation y-axis and the given curve is x is equal to g of y, it will be integral, say, from y is equal to c to y is equal to d. Twice pi, instead of y, it will be twice pi x dl again. But what is dl in this case? As we know that the arc length will be given by this one. If x is given in terms of y, it's equal to y is equal to c to y is equal to d. Twice pi x dl, it is square root of 1 plus dx dy, the whole square dy. Then later on you replace the value of x, which x in terms of y, whatever be the function given for this one. Replace it here, then you can integrate this whole thing, and then you'll get the required surface area of the solid rotating about the y-axis. Hope it is clear now how we have derived the formula for the surface area of solids of revolution when it rotates about the x-axis and at the same time when it rotates about the y-axis.